Very, very good evening to all of you. Good morning, good afternoon. I hope all of you are doing well. So, welcome to another session, another mock session in the series of BARC and NPCIL interview. So, here today in the panel with me, we have Ankur Bansal sir. Hello, sir.
Thank you, sir. Thank you for
And
introducing.
the candidate is Soumya. So, Soumya, would you like to introduce yourself?
Yes, sir. So, good afternoon, sir. My name is Soumya Jain, and I come from Surat, Gujarat. I recently graduated with a degree in chemical engineering from Sardar Vallabhbhai National Institute of Technology, Surat. Throughout my academic journey, I gained knowledge on various subjects important for chemical engineering studies, such as mass transfer operations, heat transfer operations, chemical reaction engineering, fluid flow, thermodynamics, etc. To further enhance my understanding of this domain, I undertook a vocational training with Reliance Industries, Hazira, where I studied about the polymerization of propylene in a fluidized bed reactor. With my sincerity and dedication, I have managed to maintain a decent CGPA of 9.5, and I stand fifth in my batch. Also, throughout my college days, I actively engaged in different extracurricular activities, which have helped me enhance my leadership and other interpersonal skills. Thank you for having me here today, and I look forward to becoming a part of your esteemed organization.
Sure. सब कुछ आपने बता दिया. नेक्स्ट क्वेश्चन में क्या पूछूं? उसका आंसर आपने पहले ही दे दिया. Anyways, so you said that you did your vocational training in the polymerization of some
Propylene.
propylene in the fluidized bed reactors.
Yes, sir.
So, and you are currently preparing for NPCIL.
Yeah.
So, can you tell me how this experience of training or this knowledge can help you in this?
So when I undertook my vocational training, I realized that there are many aspects of working of a chemical plant that we are not taught about during our lectures in college. For example, the working of the DCS panel or the actual setup of reactors and other auxiliary equipment in the plant, and the utilities that are there, the functioning, the working, the actual sizing of reactors and other vessels over there. So that helped me a lot to gain hands-on experience on how a chemical plant actually works. So I think that would be an additional advantage for me if I get to join this organization.
So why you want to work in the field of nuclear science here?
Sir, I believe nuclear science is an emerging field in today's time, which is a very clean source of energy. And it has a potential to meet our country's energy demands. So that's why I think I can contribute. I would like to dedicate my skill set towards this emerging field by joining your organization.
Okay, and one more thing is, you said you got around 9.5 CGPA in your BTech.
Yes.
So you have quite a good academics, and you did your BTech from NIT Surat as well.
Yes.
So why don't you want to go for masters?
So I think right now I'm more inclined towards entering into a professional setting where I can actually get to know about how things work in practical life, which I shall be missing if I go for a master's degree. And moreover, if I get to join NPCIL, then over there also I'll get to learn a lot, which I think will equally enhance my knowledge of chemical engineering. So
after masters also you can join.
That
will be more helpful for you or for us as well.
Yes, sir. Probably that may be a case, but yeah, if the recruiters don't find me eligible with my current level of knowledge, then I shall definitely consider increasing my knowledge by going for a master's or some other course. But as far as now, at this point of time, I think I should give it a try once.
Everything was okay, बस आपको ये option नहीं देना चाहिए था खुद से.
Okay.
Till now, all the answers were quite good.
Okay, sir.
if I will not, मतलब आप खुद से उन्हें choice दे रहे हो कि अगर मैं select नहीं हूँ तो I have alternative plan.
हाँ, correct.
And initially you was talking about why you want to join you NPCIL.
Yes. हाँ, right. तो मैं वो nuclear वाला point ला सकती थी. Yes.
So
हाँ, contradict हो गया.
I hope you are understanding this. Okay. Anyways, so you said you have prepared mass transfer, heat transfer, CRE, FM, and thermo.
Hmm.
So let's talk. I will ask only one question here. In a fluidized bed reactor, which you saw in industry, what was the role of entropy there?
So in fluidized bed reactor, when we pass gas through the bed of catalyst paddles, the bed starts to behave as a fluid because of the high velocities with which gas is made to flow through it. So the entropy over there is increasing, and this increase in entropy helps in better distribution of heat, and it also allows to have increased turbulence inside the reactor, which helps in increasing the rate of polymerization reaction.
So how entropy was increasing? मतलब why it was increasing?
So क्योंकि bed हमारा fluidized हो रहा है, so the particles are getting disarranged. They are पहले catalyst particles are well arranged in a bed, but as soon as the velocity is increased of the fluidizing medium, the particles are getting distributed and scattered all over the reactor bulk. So the disorder or chaos is increasing. So that's why entropy is increasing.
Okay. We will do the further discussion. Sir, let's start with.
Sure, sir. So, Soumya,
Yes,
tell
sir.
me the difference between the servo mode and the regulatory mode.
Servo, if we talk about in terms of instrumentation, a servo problem is a problem in which the set point given to our instrument is changed, and we have to execute control to accommodate this change in set point. While in regulatory problems, what we come across is fluctuation in the input variable, deviation in the input variable from the set point. Set point is fixed, but the input variable is different. So to make it to the set point, we can execute a control strategy. So that is a regulatory problem.
In chemical engineering, which is more useful or which is more practical for us?
So more frequently, we come across regulatory problems.
Okay, take it. So, in a feedback control loop, how many components are there?
In a feedback control loop, first we have the process. From the process, we get the variable, which is then measured using a measuring element. This measuring element is then set to the comparator that compares its value with the set point and generates an error signal. This error signal is then sent to the control element, which takes the appropriate action to correct this error, and that is how the deviation from set point is resolved in a feedback controller.
After the controller, what you said?
The controller takes the necessary action on the process, and that's how the error is mitigated in a feedback control.
No, but controller only decides what to do. Controller does not actually do the things.
Sorry, controller से signal final control element पे जाएगा, then final control element will take the action.
Okay. And for chemical engineering things, what is final control element?
So it is mainly a valve.
Valves. And how many types of valves are there?
So there are many types of valves, such as gate valves, globe valves, butterfly valves, needle valves.
No. The controller is attached to the valve.
Yes, sir.
Controller sends the signal to the valve.
Yes.
Based on the signal sent, how many types of valves are there?
So एक तो pneumatic valve होती है. Then we have electric. I am unable to recall all the types, but like pneumatic हो गया, which sends the signal in form of air pressure. The electric valve अगर कुछ it sends in terms of electric signals, and rest I'm unable to recall at this moment.
Okay, good. So in the case of pneumatic valve, there are two types of valves generally, because in case of when compressed air is coming, either the valve can open or the valve can close. So there are
Yes.
two types of valves. On the basis of that, differentiate between those two.
So one is air to open valve, and the other is air to close valve. In air to open valve, we need to send air to open the valve. So when air is passed, the diaphragm of the valve is pulled up. As a result, the valve opens up. But when in air to close valve, when air is passed, the diaphragm of the valve is pressed against the its base. So that is why the valve gets closed and flow through the pipe stops.
What is the purpose of plug that is present at the bottom?
So a plug ही है जो valve की opening और closing को control करता है. तो valve पे pressure बनेगा तो plug नीचे move होगा और valve close हो जाएगी in air to close systems, and in air to open valve valve के diaphragm पे pressure पड़ेगा तो valve will uplift, so it will
So keeping the entry of the air same. Okay, and keeping the motion of the actuator same, that as the air pressure increases, the actuator moves downwards. Keeping that same, can we design air to close and air to open differently?
So depending upon the valve characteristics,
So don't go into the valve characteristics. Just
Okay.
listen again. The entry of the air is same. It is above the diaphragm.
Okay.
Air pressure is increasing, so the diaphragm moves down, and the actuator attached to the diaphragm is moving down. So in the air to open as well as in the air to close, if this is happening, then what single change we need to do in order to change the nature? Means one
plug
is air to
की
open.
shape को
Yeah,
plug
yeah.
की shape को change करना पड़ेगा.
We need to use the reverse plug.
हाँ.
Okay. So which is more easy for us? Using the different air entries or changing the plug position?
Different air entries को use करना, because plug एक बार design हो गया तो फिर बार-बार उसे change करना.
तो entries भी तो problematic नहीं है, एक बार नीचे से दे रहे हो और ऊपर से दे रहे हो. Obviously अगर आपने किसी सिस्टम में air to close valve यूज करी है तो air to close ही है ना. ऐसा थोड़ी है कि 2 दिन बाद उसे air to open बनाना है.
हाँ, correct.
अगर एक बार प्लग आपने रिवर्स कर लिया तो कर लिया.
हाँ.
या एक बार एयर की एंट्री एक तरफ से आ गई तो आ गई. बार बार थोड़ी चेंज करेंगे उसको, तो नहीं करेंगे.
हाँ.
तो द क्वेश्चन इज, अगर मुझे वॉल्व बनानी है तो क्या स्टैंडर्ड मुझे फॉलो करना है? सेम प्लग पोजीशन का स्टैंडर्ड मुझे फॉलो करना है और एयर की एंट्री को डिफर करना है, या सेम एंट्री को स्टैंडर्ड मुझे फॉलो करना है और प्लग की पोजीशन को डिफर करना है?
So plug की पोजीशन को चेंज करना पड़ेगा.
वो ज्यादा इजी है.
हाँ.
ठीक है, वो ज्यादा इजी है, बट स्टैंडर्ड दूसरा है.
ओके.
ठीक है, वो ज्यादा इजी वो लगता है हमें, बट जनरली स्टैंडर्ड हम दूसरा रखते हैं. तभी एयर टू क्लोज एयर टू ओपन की जब डेफिनेशन आपने दी तो ऐसा नहीं बोला कि हमने प्लग चेंज कर दिया, आपने बोला कि हमने एयर की एंट्री चेंज कर दी. दैट इज व्हाई द डेफिनेशंस आर ऑन द बेसिस ऑफ द एंट्री ऑफ द एयर.
ठीक है.
ठीक है. इन द केस ऑफ पी, पीआई, पीआईडी, व्हिच इज द फास्टेस्ट?
प्रोपोर्शनल कंट्रोल.
पी इज फास्टेस्ट.
हाँ, पी.
faster than PID?
सर PID में P और PN like
P-
इंटीग्रल मोड जब हम
P versus PI versus PID.
हाँ,
Again, I'm repeating the question. Out of P, PI, PID, which is fastest? Before answering the question, you should think, what do we mean when we say fastest?
सर प्रोपोर्शनल कंट्रोलर फास्ट होता है बट उसका यूज इतना एफिशिएंट नहीं होता है. PNID भी फास्ट होता है.
What do we mean when we say
Fast.
fastest?
जो सेट पॉइंट तक सबसे जल्दी पहुंचा दे.
जो सेट पॉइंट तक जल्दी पहुंचा दे.
हाँ,
सेट पॉइंट तक जल्दी पहुंचा दे या एरर को जल्दी जीरो कर दे? कंट्रोलर का काम क्या होता है?
हाँ, एरर को जीरो करके.
एरर को जल्दी जीरो कर देना.
हाँ,
प्रोपोर्शनल कंट्रोलर के अंदर एरर जीरो हो पाता है क्या?
नहीं नहीं, उसमें ऑफसेट रह जाता है तो PNID
जाता है।
फास्टेस्ट.
तो फिर तो PID हो ना.
PNID, हाँ, PID सॉरी, PID.
ठीक है. तो PID में ऑफसेट क्या होता है?
PID में ऑफसेट नहीं रहता है,
कितना होता है?
0.
PI में?
PI में ऑफसेट रह जाता है. और
ऑफसेट को जीरो कौन कर रहा है? P कर रहा है कि I कर रहा है कि D कर रहा है?
सॉरी PI में ऑफसेट नहीं होगा. ऑसिलेशंस इंट्रोड्यूस होता है इंटीग्रल मोड से बट दैट मेक्स ऑफसेट 0. P कंट्रोलर में ऑफसेट रहेगा. PNID में भी बिकॉज ऑफ इंटीग्रल मोड ऑफसेट नहीं रहेगा. PI PNID में नहीं रहेगा एंड P में रहेगा ऑफसेट.
PD में?
PD में भी रहेगा.
ID में?
ID में नहीं रहेगा.
ID होता है?
ID होता नहीं है.
तो फिर आप कह रहे हो नहीं रहेगा.
हाँ, कंट्रोल मोड ही नहीं है कोई.
और I में?
I भी सिंगल यूज नहीं करते.
ठीक है. हम P को तो सिंगल यूज करते हैं,
हाँ,
प्रोपोर्शनल एक्शन बोलते हैं, बट I और D को सिंगल यूज नहीं करते. ऐसा क्यों? P में भी P है, PI में भी P है, PID में भी P है. P हमेशा है.
हाँ.
और PD में भी P है. बट I और D अकेला कहीं नहीं है कहीं पे. कोई तो रीजन होगा ना. ऐसा क्या करता है P जो I और D नहीं कर पाते?
P कंट्रोल जो है एरर के प्रोपोर्शन में करेक्टिव सिग्नल जनरेट करता है.
एरर के प्रोपोर्शनल में? आपको पता है P एक्शन, I एक्शन और D एक्शन तीनों काम तो एरर सिग्नल के बेसिस पे ही करते हैं.
हाँ,
बट तीनों डिफरेंट एरर सिग्नल्स के बेसिस पे काम करते हैं. मतलब P जिस एरर पे काम करता है I उस पे काम नहीं करता. I जिस पे काम करता है D उस पे काम नहीं करता. तीनों के एरर्स अलग अलग है.
ओके. तो मुझे डिफरेंशियल मोड का पता है. डिफरेंशियल कंट्रोलर जो है वो स्टेप इनपुट पे काम नहीं कर सकता है.
वो तो इनपुट चेंज है ना फिर. मैं तो एरर की बात कर रहा हूँ.
अच्छा, ओके. तो सर इसका आइडिया मुझे अभी
कोई बात नहीं, मैं हिंट देता हूँ. आप टाउडी की डेफिनेशन बता सकते हो डेरिवेटिव टाइम की?
टाउडी. एक सेकेंड सर.
हाँ श्योर.
सर टाउडी वो टाइम है, टाइम ड्यूरेशन जिसके बाद डिफरेंशियल कंट्रोल मोड अपना एक्शन रिपीट करता है।
डिफरेंशियल कंट्रोल मोड अपना एक्शन रिपीट करता है? नहीं, ये डेफिनेशन नहीं है।
अच्छा,
टावाई की डेफिनेशन बताओ।
टावाई इज द रीसेट टाइम जिसके बाद इंटीग्रल कंट्रोल मोड अपना एक्शन जो है वो रिपीट करता है।
यही आपने टाउडी के लिए बताया।
हाँ, मैं गलत बोल रहा हूँ। टावा इज द रीसेट टाइम जिसके बाद हमें अपने इंटीग्रल कंट्रोलर को रीसेट करना। तो मैं कंफ्यूज हो रही हूँ।
टाउडी टाइम टेकन है या टाइम सेव्ड है?
टाइम सेव्ड।
टाइम सेव्ड है। मींस टाउडी टाइम लगता नहीं है, स्पेंड नहीं हो रहा है।
हाँ,
मतलब डी एक्शन टाउडी टाइम लगाता नहीं है, टाउडी टाइम
बचाता
बचाता
है।
है।
हाँ,
बचा कैसे रहा है वो?
सब वो रेट ऑफ चेंज ऑफ एरर पे काम करता है।
और रेट ऑफ चेंज
हाँ,
डी बाई डी टी
हाँ,
ये हमें क्या बता रही है? अगर मैथमेटिकली देखे तो डेरिवेटिव होता है टेंजेंट,
हाँ,
टेंजेंट टू द कर्व।
हाँ,
तो कोई एरर कर्व है, उस पर टेंजेंट डाली।
हाँ,
टेंजेंट डालने से हम क्या प्रिडिक्ट कर सकते हैं?
कि वो कितनी जल्दी फाइनल पॉइंट पे पहुंचेगा।
नहीं, कि वो किस रेट से चेंज हो रहा है।
हाँ, किस रेट
ये
से चेंज।
चीज ये चीज प्रिडिक्ट कर सकते हैं।
हाँ,
इसका मतलब नेक्स्ट एरर जो आने वाला है वो
उसको
कैसा आएगा?
प्रेडिक्ट।
कम
हाँ,
आएगा कि ज्यादा आएगा कि नेगेटिव आएगा कि पॉजिटिव आएगा? डेरिवेटिव यूज करके उसे प्रिडिक्ट किया जा सकता है।
हाँ,
और जब मुझे पहले से ही पता है कि नेक्स्ट क्या आने वाला है तो उसके अकॉर्डिंगली मैं कंट्रोल ले सकता हूँ। जैसे कि हम फीड फॉरवर्ड स्ट्रेटेजी में करते हैं
हाँ,
कि पहले से ही हमें पता होता है डिस्टर्बेंस के चेंज को, तो हम अपने सिस्टम को पहले से रेडी कर देते हैं। तो डी एक्शन टाइम बचा लेता है, क्योंकि डी एक्शन तब काम करता है जब हमारा कंट्रोलर अपना काम कर चुका होता है। उसके बाद जब सिग्नल प्रोसेस में है, मेजरिंग एलिमेंट उसे मेजर कर रहा है, ट्रांसमिशन वायर्स के थ्रू वो जा रहा है, उसमें डी काम कर रहा है। तो जब तक एरर एक्चुअली में पहुंचता है, डी अपना काम कर चुका होता है। तो
ओके,
डी फ्यूचर एरर्स पे काम करता है।
अच्छा, ठीक है।
तो अगर मैं अकेला डी यूज करूंगा तो वो तो बेचारा सिर्फ फ्यूचर एरर पे काम करेगा।
हाँ, प्रेजेंट एरर का काम है।
तो प्रेजेंट एरर पे तो काम ही नहीं हुआ।
हाँ,
इस वजह से डी के द्वारा कंट्रोल की गई प्रोसेस कभी स्टेबल हो ही नहीं पाएगी।
राइट।
सेम इज द प्रॉब्लम विद आई।
आई
अब आई किस पे काम करता है?
आई जितनी एरर अब तक आ चुकी है।
इज इट जीरो टू टी
हाँ,
ईटीडीटी? तो
हाँ,
जीरो टू टी ईटीडीटी मींस व्हाट?
combination of all the errors that we have received till now.
In the past.
In the past.
So that works on the past errors only.
हाँ,
And what is proportional controller is KCET.
हाँ,
So that
present
KCET
error.
is actually the present error.
Okay.
Okay. And that is why we always say ना कि present में रहना बहुत जरूरी है।
हाँ,
प्रेजेंट होगा तो ही हम फ्यूचर को बना पाएंगे, और पास्ट इसलिए जरूरी है ताकि मिस्टेक से हम सीख पाए। बट हम प्रेजेंट या प्रेजेंट को छोड़ के पास्ट या फ्यूचर में रहेंगे तो हमेशा लॉस्ट रहेंगे। So that's why P is always there. P, PI, PID, PD. The presence of P is very, very important.
Okay, sir.
What are the types of first order systems?
Types of first order systems. Examples. Mercury thermometer, then water level inside a tank, then first order reaction in a CSTR, then
First order reaction in a CSTR is a system.
Concentration. So, एक heating tank system.
When you say that the given system is a first order system,
when there is a linear relation between the output variable and input variable.
that means y is equals to mx.
Yes.
But in y is equals to mx, there is no derivative. That is not even a system. Why it is first order system? What is the definition of first order system? The systems that are represented by the first order differential equations are known as the first order system.
Sorry.
What happened?
Sorry, sir.
Write down the first order differential equation then that represents the first order system correctly.
Yes. Sir, tau dy by dt plus t is equal to kp times function of t.
Tau p into dy by dt plus t.
Y. Tau into dy by dt plus y is equal to kp times function of t.
What is this?
So this is the relation between output variable y.
No, this is a first order differential equation.
No?
This is first order differential equation, or you want to add something in this?
Maybe first order.
Okay. So write down an equation, tau p, write it down, tau p, dy by dt whole square plus yt is equals to kpft. So is this the first order differential equation?
First order 3.
But will this be the represent the first order system?
First order first degree differential equation से जो
मैं
represent
पूछ रहा था, you want to add something or not?
हाँ, first order first degree differential equation से जो
First
system
degree or linear?
linear degree.
Linear.
हाँ.
Linear first order.
हाँ, linear first order. Yes.
Anything else you want to add? Yes, no?
No, sir.
Okay. Then instead of dy by dt, if I have used del y by del t, then tau p into del y by del t plus yt is equals to kpft. That is also a first order differential equation. but that will not represent the first order system and will not come up as Kp by tau ps plus 1.
Right. So linear first order ordinary differential equations. Say first order system defined of that.
Anything else you want to add? What is the coefficient of dy by dt?
Coefficient should be a constant.
Yeah. So linear first order ordinary differential equation with constant
leading
coefficients
coefficient
will lead us to the transfer function that we study, which is Kp by tau ps plus. So that is not just first order. That is linear ordinary first order with constant coefficients. That's the difference.
Yes.
Okay. Write down the correlation for a spherical naphthalene ball diffusing into the moving air. Correlation of Sherwood, Reynolds, and the Schmidt.
Sir, actually, मेरे को exact correlation याद नहीं, but it's something like Sherwood number is equal to 2 plus Reynolds number raised to 0.33 or into Schmidt number raised to 0.8 something.
No issue. ठीक है. Just write down a general relation like Sherwood is equals to 2 plus A times Reynolds की power B, Schmidt की power C. Write it in this way. No issue. Okay. So in this correlation, if air is not moving, if air is stationary, then what will be the value of the Sherwood number?
2.
Why?
Because Reynolds number 0 बन जाएगा. Since velocity is
Why Reynolds number is 0?
Because Reynolds number is rho times velocity of air into so velocity of air अगर 0 होगी, then Reynolds number is 0.
Okay. Have you heard or read about zero Reynolds number in any book of this world? Zero Reynolds number. Have you heard? Have you read?
नहीं. Stationary mentioned रहता, zero Reynolds number कहीं mentioned.
Stationary mentioned है.
हाँ.
Air is not moving. Air is not moving. Air is stagnant. But the point is, you said zero Reynolds number. Reynolds number, can Reynolds number be 0? What is the purpose or the significance of the Reynolds number? It tells us about the nature of the flow, whether it is laminar or turbulent. क्या Reynolds number हमें stagnation के बारे में बताता है? No.
नहीं.
ये बताता है कि laminar है या turbulent है. तीसरा ऑप्शन ही नहीं है.
हाँ.
Then you are saying Reynolds number is 0.
If you go by the definition, that itself tells the same story.
Okay.
Sherwood number is 2. That is correct answer. But that is not because what you said. Okay, leave. Tell me what is the relative volatility? How you define relative volatility?
Relative volatility is defined as the ratio of mole fraction of the solute in the more volatile. So just a minute. For a binary system, the relative volatility of component A with respect to B can be defined as the mole ratio of A in gas phase to mole ratio of A in the liquid phase, and this divided by the same ratio for component B.
Wrong. फिर से बताओ. You said mole ratio of A in gas, then in liquid to the same ratio for B. You have interchanged some terms. What is the formula?
YA by XA upon YB by XB.
Okay, YA by XA upon YB by XB. You are writing like this. Write it like this: YA by YB upon XA by XB.
Oh,
Generally, it is defined like this:
okay.
mole ratio, or
Mole
not
ratio.
mole ratio, mole fraction ratio of A to B, A to B.
In the gas phase to the same ratio in liquid phase.
Still, it is wrong. Is there any gas in distillation?
Vapor phase. In the vapor phase to the same ratio in liquid phase.
Okay. Which law is used for the distillation to define the VLE? वेपर लिक्विड इक्विलिब्रियम को दिखाने के लिए कौन सा लॉ यूज किया जाता है?
सर यूजुअली हम राल्स लॉ यूज करते हैं.
Define Raoult's law.
Raoult's law says that the partial pressure exerted by a component over its liquid solution is directly proportional to its concentration in the liquid solution. And if we add the proportionality constant comes out to be the vapor pressure of that pure component at the same temperature.
Good. For the case of absorption, which law is used to represent the equilibrium?
Same law.
Raoult's law.
Execute. Sir, Raoult's law use करेंगे.
Okay. Absorption is a vapor liquid systems.
No, it's a gas liquid system.
But Raoult's law you said used to represent VLE.
Vapor liquid system. So
Absorption is not vapor liquid system.
तो absorption use नहीं करेंगे.
तो फिर कौन सा यूज करेंगे? You must have solved numericals for absorption in GATE exam. You must have solved some law, na? What is that law? Okay, let me help you. It's Henry's law. Okay, can you define Henry's law?
Yes, Henry's law states that the vapor pressure, just a minute. The mole fraction of component in the vapor phase is directly proportional to the mole fraction of the same component in the liquid phase, where the proportionality constant is the Henry's constant.
That is not the original form of Henry's law. Modified form है ये तो. The original form of the Henry's law is PA is equals to H into CA.
Concentration.
Define again.
The partial pressure exerted by a component over a solution is directly proportional to its concentration in the solution, and the proportionality constant is the Henry's constant.
Why the Henry's law is used in the case of absorption and not any other law? Any special reasons?
Sir, I guess Henry's law हम तब यूज करते हैं जब solute की concentration low होती है, तब वो valid रहता है.
Means dilute systems.
The dilute systems. Yeah.
Absorptions are dilute systems?
Yes.
Okay. Absorptions are equilibrium. Absorption is an equilibrium phenomena?
No.
Then why we use Henry's law there? Henry law is used to represent the equilibrium between y and x, na? But absorption is not an equilibrium phenomena.
So to find out the minimum solvent rate, हमें equilibrium curve की जरूरत पड़ती है. Then वहाँ से हम actual solvent rate निकालते हैं. And then उस operation में use करते हैं.
So what is this process called as? Minimum solvent, optimum solvent? The name of the process क्या है?
Designing the absorption operation.
Or optimizing it?
Optimizing.
Ankush Gupta sir?
Yes, sir.
तिवारी के कुछ क्वेश्चंस पूछ लो आप.
Yes, sir. उससे पहले मैं FM के पूछना चाहूँगा.
Sure.
Like you guys had some discussion about the Sherwood number, Reynolds number and all. So I just want to know one thing. Can you define what is total pressure on the submerged surfaces?
On submerged surfaces. Total pressure will be equal to the मतलब total normal pressure जो उस पे exert हो रहा है चारों तरफ से.
Total pressure also known as hydrostatic force.
Okay, so that will be rho GH. अगर that is submerged at a height h.
Rho GH only.
Rho GH plus atmospheric pressure.
Rho GH has the unit of Pascal, and I am talking about the total hydrostatic force, which should have the units Newton.
So pressure, hydrostatic pressure multiplied by surface area of the body.
What is hydrostatic pressure?
Hydrostatic pressure is the pressure exerted by a column of fluid by a particular height of column of liquid at its base.
It is due to what?
It is because of the reason तो मेरे को click नहीं हो रहा है.
What is rho G? Rho into G.
Specific gravity. No, specific weight. Weight density. Gamma is
Meaning is same.
हाँ.
So that is the answer. Hydrostatic force is due to the gravity, weight of the fluid.
हाँ, ठीक है.
यही तो बोलना है आपको.
हाँ, मेरे को एक्चुअली क्लिक हुआ था, but then मैं
हमने एडवांस टॉपिक कर लिए ना, बेसिक फंडामेंटल्स भूल गए. So एडवांस टॉपिक पे आते हैं फिर. Do you know about the Bernoulli principle?
Yes, sir.
What is that?
Sir, according to Bernoulli's principle, for an ideal inviscid fluid along a streamline, the total in steady state, the total head of the fluid, total head energy of the fluid remains constant.
What is total head energy here?
Total head is the sum of pressure head, the dynamic head, and the head possessed by it because of its elevation.
Elevation head. potential head, you can say.
Potential.
Make one correction. This is a total mechanical head.
Okay.
Or you can say total mechanical energy. And one more correction is, you said, what you said? Can you ideal in viscid fluid, you said.
But
What-
ideal fluid in viscid.
Ideal fluid, what is in viscid fluid?
जिसकी viscosity नहीं होती,
Zero होती है.
zero होती है.
And what is ideal fluid?
हाँ, वो उसमें include हो गया. Ideal repeat नहीं करना चाहिए.
So either say ideal fluid or just say in viscid fluid.
ठीक है.
Okay. Anyways, so can you do you know about the steady flow energy equation?
Steady flow energy equation.
You said thermodynamics as your fifth subject.
हाँ. So steady flow energy equation.
In thermodynamics, first law of thermodynamics when we apply for open systems.
अच्छा, okay. हाँ. So the change in enthalpy plus the kinetic energy and the potential energy will be equal to heat exchange and shaft work.
Heat exchange and shaft work. What is happening? Multiplication, addition, division.
Sum of heat work and sum of heat exchange between the system and the surroundings, and the shaft work done by the system.
That is equal to heat and work, you said. So what is that and means? Multiplication between heat and work, addition between heat and work, subtraction between heat and work, or what?
Addition between heat and.
There is a correction required. It is like, what is first law of thermodynamics for closed system?
Delta U is equal to Q plus W.
Q plus W, you are saying. So what is Q means there?
Q is
Physical meaning.
Q is the heat added to the system.
And what is W there?
Work done on the system.
Correct. And if you add, you must have seen first law as delta U is equal to Q minus W also. Somewhere, I believe. So in that case, Q is the same heat addition, but W will be the heat, W will be the work done by the
system.
So there should be a difference always. So similarly, in the steady flow energy equation, when you are talking about the Q and W there, so define their meaning.
ठीक है.
Q, if you are writing like Q plus W, as you said, addition. So in that case, Q will be the heat added
to the system, and W will be
WS will be the shaft work
done on the system.
And if you write it as minus, it will be shaft work done by the
system.
So now my question is, from this steady flow energy equation, can you drive the Bernoulli equation? Say yes or no first.
हाँ सर, कर सकते हैं.
What will be the assumptions you will take?
एक तो सिस्टम में कोई एनर्जी नहीं आ रही है, तो Q and WS will be 0 सबसे पहले तो. Then
Why they are zero, by the way? Why we take this assumption? The answer is hidden in Bernoulli principle itself.
So, क्योंकि हम एक streamline element पे Bernoulli equation.
What is mainly Bernoulli equation principle? Sum of all mechanical energies of the fluid element. Correct? So if any external interaction of energy will occur, that will disturb the existing energy of the fluid. That's why. You should say extra if they ask any such thing. Why is zero? Because we don't want any external disturbance.
Okay.
So, and next assumption.
Yes, sir. The change in internal energy is negligible.
Why?
Because temperature fluctuations हम इतना consider नहीं कर रहे हैं.
क्यों नहीं करते? सेंसर्स महंगे हैं.
नहीं.
Because of no external energy.
हाँ.
If Q and W are not there,
हाँ तो
U will be
temperature
zero.
change नहीं होगा.
So, and any other assumption? In a steady flow, you energy equation, you say change in enthalpy. That is H2 minus H1. What is H2?
U2 plus P2 V2.
And what is H1?
U1 plus P1
V1. So in Bernoulli equation, what we write? P1 upon V1 or P1 upon rho? Means the density we take with P1 and P2.
Constant. Fluid ka flow incompressible.
Yes. See how easy it is. If you just look at the equation, you will get to know what are the assumptions. We don't need to remember the assumptions as such if we are clear with the equation. So then you can get those things. Now, one more question here. Can you tell me the difference between thermal diffusivity and momentum diffusivity? Difference I'm talking about.
So thermal diffusivity बताता है कि कोई हमारे सिस्टम में से हीट कितना रैपिडली डिफ्यूज हो सकती है, while momentum diffusivity बताता है कि momentum transfer कितना रैपिड हो सकता है.
So what will be the difference between momentum diffusivity and dynamic viscosity?
Momentum diffusivity is equal to dynamic viscosity upon density.
I'm not asking the relation, and I'm asking the difference.
Okay. Sir, dynamic viscosity actually viscous forces जो operate कर रहे हैं उनका absolute measure देगी, जबकि momentum diffusivity viscous forces जो initial forces का relative strength कितनी है उसका idea देगी, because it's mu.
Dynamic viscosity की units क्या होती हैं?
Dynamic viscosity Newton second. Pascal second.
So that will be Newton second per meter square. Newton is coming. Newton is a unit of force. तो आपका आंसर सही है, विस्कस फोर्स का मेजर है. What is units of kinematic viscosity? That is momentum diffusivity.
A meter square per second.
Do we have any force units here?
No.
And how can it tell about the strength of forces or something? Force कब होगा? What is force? M into A. अगर मास ही नहीं है तो फोर्स भी नहीं होगा. तो डायनेमिक विस्कोसिटी में तो मास आता है यूनिट्स में भी.
हाँ.
इसलिए फोर्स भी आ रहा है. काइनेमेटिक विस्कोसिटी में तो हमने मास का टर्म ही एलिमिनेट कर दिया. तो यहाँ पे फिर फोर्स की बात कैसे कर सकते हैं? अगर आप यूनिट्स को ब्रेक डाउन करो, ये कैसे लिख सकते हो आप? मीटर पर सेकेंड इनटू मीटर.
हाँ.
व्हाट इज मीटर पर सेकेंड? किसका यूनिट है ये?
वेलोसिटी.
वेलोसिटी मींस मोशन.
मोशन. हाँ.
तो यही तो मोमेंटम डिफ्यूजिविटी है. हाउ इजीली मोमेंटम कैन ट्रांसपोर्ट. यही तो बताता है बस.
हाँ.
और डायनेमिक विस्कोसिटी is about the resistance between the fluid layers. That is the viscous force you said.
हाँ.
तो डायनेमिक विस्कोसिटी हमें क्या बता रहा है? रेजिस्टेंस. रेजिस्टेंस is the measure of oppose of that momentum transfer.
हाँ.
तो I hope you got the point.
हाँ.
इसे आप एक बार नोट्स में चेक कर लेना, आपको क्लियर आइडिया लग जाएगा how you have to answer this.
Yes.
ठीक है. What is the fundamental unit of heat?
Joule.
What is 1 joule? How will you define 1 joule?
So 1 joule is the energy required to so water का temperature raise करने में जितना something related to that.
Joule, 1 joule is equal to 1 Newton meter.
हाँ.
W equal to F into D.
The energy dissipated when a body of 1 kg mass is moved moved by a distance of 1 meter.
Distance or displacement?
Displacement.
In the same direction, in the direction of force.
हाँ.
ठीक है. अब ये कोई ऑब्जेक्ट है, मैं अगर फोर्स ऐसे लगा रहा हूँ और ऑब्जेक्ट इधर शिफ्ट हो रहा है, तो वो वर्क नहीं होगा ना F into D. वहां फिर कंपोनेंट आ जाएगा.
हाँ.
1 joule is the work done on a system of 1 kg mass to displace it by 1 meter.
1 meter.
The direction of
motion.
Force.
ठीक
है. तो यहाँ पे कहीं पे हीट की बात आई, टेम्परेचर की बात आई
नहीं.
तो फिर जूल हीट का फंडामेंटल यूनिट कैसे हुआ? ये तो वर्क का हुआ ना.
हाँ.
डेफिनेशन से
हाँ.
वर्क आ रहा है इसमें, तो वर्क का फंडामेंटल यूनिट. तो हीट का फंडामेंटल यूनिट क्या होगा?
कैलोरी.
करेक्ट. और व्हाट इज 1 कैलोरी?
1 calorie is the amount of heat required to raise the temperature of 1 kg water by unit 1 kg ice.
1 gram.
1 gram, sorry. 1 gram of water by unit temperature difference.
That's why Cp of water is 1 calorie per gram
centigrade.
per degree Celsius or Kelvin or whatever you like to say. ठीक है. Wonderful. तो यहाँ पे अब आप मुझे एक चीज बताओ. Suppose we have a water tank at the ground floor and we want to supply the water. 2 scenarios are there. First scenario, I want to supply the water up to the 10th or 20th floor of a building. So which pump arrangement would be better? Centrifugal pumps in series or centrifugal pumps in parallel?
Sir, I guess parallel would be a better configuration.
Yes.
क्योंकि उसमें फ्लोरेट जो है डिस्ट्रीब्यूट हो जाएगा तो इंडिविजुअल पंप पे फिर कम पड़ेगा. ऑल्सो अगर हम सीरीज में लगाएंगे तो लॉसेस ज्यादा होंगे.
चलो मैं आपको दोनों सिनेरियो बताता हूँ, आप फिर उसके अकॉर्डिंग सोचो और बताना. First scenario is we want to transport the water up to a very high altitude, high elevations, like 10th, 28th or 50th floor. ठीक है? And second scenario is we want to transport the water for a long distance, let's say up to 100 kilometer, 200 kilometer, something like this. ठीक है? So you have, I hope now it can help you to understand.
सर हमें फिर यूजुअली जब लॉन्ग डिस्टेंसेस से हमें पंप कराना होता है तो हम मल्टी स्टेज पंप्स का यूज करते हैं जहाँ पे एक से ज्यादा इम्पेलर्स लगे होते हैं. तो उस व्यू पॉइंट से देखें तो हमें सीरीज पंप्स का यूज करना पड़ेगा ताकि मल्टीपल इम्पेलर वाला अरेंजमेंट अचीव हो सके.
Okay, and for altitudes?
For altitudes, के लिए फिर सेम लॉजिक से सीरीज वाला कॉन्फ़िगरेशन बेटर रहेगा.
Sorry?
एल्टीट्यूड्स के लिए भी फिर हमें सीरीज अरेंजमेंट के लिए जाना चाहिए.
Yes, for a high altitudes we need series.
Series
Pumps and
arrangement.
series because pumps क्या करते हैं? Pumps increases the pressure head.
Pressure energy. हाँ.
So if we are using pumps in series, so pressure head will
Increase, keep on increasing.
increase. But when we talk about the pumps in parallel, then they are not increasing the pressure heads overall.
Yes, correct.
The pressure head of both the pumps will be different.
Right.
So, whole of story. Okay. So that's fine. So, sir will give the feedback, then I will tell you my feedback. बाकी already काफी time हो गया.
Feedback ये है कि you look confident, but sometimes you look little lost.
Okay.
Sometimes you are look here, you know everything. At some other times you know it likes you don't know anything. I'm not getting. I'm actually confused what type of feedback I give you, because this interview is not actually average. Either it is above average or below average.
Okay.
Generally, the interview should be at average and for the selection.
Okay.
So it looks like that if the questions are in your range, you will hit a 6. Otherwise, you will bold. You will get out. That is a type happening here actually. Okay. So I would just say all the best and wish you luck, because there is no problem of confidence with you. You are confident, and the clarity of thoughts are there. The clarity of answers are there. You are good at picking up the hints. That is also a good thing. Okay. But what will happen in the NPCIL interview, that is, I don't know. Means what
depends on topic actually. Koi topic strong hai to.
Yeah, what type of questions they will ask. So I would just say fingers crossed that they will ask questions which are in your range, so that you can give answers with the same way that you are giving here, and you will get selected.
Thank you, sir.
Because एक दो दिन में कुछ हो नहीं सकता ना, तो मैं ज्यादा कुछ नहीं बोल रहा. अंकुर सर.
बाकी जैसे सर ने बोला, फीडबैक यही है कि आपकी नॉलेज अच्छी है. जैसे आपने स्टार्टिंग में इंट्रोडक्शन दिया था, वहीं से आपका कॉन्फिडेंस पता चल रहा था. बस एक चीज का ध्यान रख, जैसे अभी हम सेशन के थोड़ा लंबा हुआ तो ऐसा फील हुआ बीच बीच में आप थोड़ा फोकस लूज कर रहे हो मे बी.
Okay.
ठीक है, तो वो नहीं करना है. ट्राई टू मेंटेन द सेम एनर्जी लेवल थ्रू आउट. आई नो इट इज डिफिकल्ट, बट इट इज जस्ट अ मैटर ऑफ दैट 1 hour. दैट विल हेल्प यू अ लॉट. और कुछ जगह आप जैसे आंसर दे रहे थे तो थोड़ा सोच के आंसर दो. क्योंकि अगर कनेक्टेड क्वेश्चंस हैं तो कॉन्ट्राडिक्टरी स्टेटमेंट्स नहीं होने चाहिए आपके। ओके, तो उससे ऐसा लगता है कि फिर आपने जो पीछे आंसर दिया था वो फेक था या फिर अभी फेक है, पता नहीं, है ना। तो ऑल्दो दैट इज नॉट द केस इन फॉर यू, बट इट लुक्स लाइक दैट। तो अपनी एनर्जी और स्माइल मेंटेन करके रखना, वही काफी होता है। अगर आप एनर्जेटिक रहोगे तो पैनल भी अच्छा फील करेगा कि हाँ कितना लाइवली पर्सन हमारे सामने आया है। तो दे ऑल्सो वांट टू टेक दोज पीपल, दिस टाइप ऑफ पीपल। तो अगर कहीं कुछ क्वेश्चंस आपको नहीं भी आते, आप सीधा मना कर सकते हो, ठीक है। तो उस केस में या गलत भी हो गए तो वहां पे वो उस चीज को इग्नोर कर देंगे, क्योंकि अगर आपकी एनर्जी अच्छी है, पॉजिटिव है तो। ओके, एंड दूसरा, जैसे एक चीज है, हमने जगह जगह बीच में कई जगह हिंट दिए तो आप उसका आंसर कर पा रहे थे। तो ये फोकस इसलिए वहां मेंटेन रखना है क्योंकि बार्क एनपीसीआईएल में आपने बार्क में दिया है तो आपने नोटिस किया होगा, if you are giving the answer and you are stuck at some place, so they will give you the hint. तो आपको वो कैच करने हैं।
हाँ।
अगर उस हिंट से आपने आंसर दे दिया तो बहुत बढ़िया, ठीक है। बाकी अपना कॉन्फिडेंस के साथ जाओ, स्माइल और एनर्जी के साथ इंटरव्यू दो, सब बढ़िया होगा, कोई टेंशन वाली बात नहीं है। और जो छोटी मोटी चीजें हैं, एक दो जगह फंडामेंटल्स वो देख लेना, अगर आपका मूड हो तो, नहीं तो कोई दिक्कत नहीं है।
ठीक है सर, श्योर।
ठीक है, ओके, थैंक यू एंड ऑल द बेस्ट सौम्या।
Yeah, thank you so much, sir. Thank you.
Thank you. Thank you.